All right, so looking at your notes. Yeah. All right. So these are all the different types of things we're going to do to find characteristics. Yes. I put them down on your group.
Yeah, I don't have it.
So Blaine took all three. I have one that you guys can look at. All right. Just take good notes on a separate sheet and then I'll reprint the pictures for you, okay? You'll have everything. I just can't print it right now. All right. So if we look at this, we have three different pieces to the piecewise function. So if we're trying to evaluate the function for -6, where should we plug -6 in? What piece? But we got three pieces. Which one are we allowed to plug it into? Mason, is that prison time? Where does the -6 get plugged in? Think about all these. Where is it allowed to be plugged in? In all of them? Plug it into all three of them? No. Plug it into the first one, because what does the first one say? Any place where x is less than or equal to -2, that's when you're allowed to use it. So if we have x equals -6, it can only be plugged into the first one. It cannot be plugged into the other ones, because that's where -6 shows up. So for the first one, I'm going to say -6 plus 3 to the third. And what would I get? -6 plus 3 is -3, -3 to the third, -27, okay? So the next one says we're going to plug in -2. Which one am I allowed to plug -2 in for? The first one, because the first one says I can use it if it equals -2. The second one says if it's greater than -2 but less than 3. The first one says we can equal -2. So I'm going to plug it into the first one. -2 plus 3 cubed is 1. 1 cubed is 1. Which one do I get to plug 0 into? I have to choose the one that we're the second one, because 0 is in between -2 and 3. So if I plug 0 in, I get the square root of 0 plus 3, which is square root of 3, right? That's some sort of decimal. Which one can I plug in 3 for? Yeah, the bottom one, so it's just going to equal -2. There's no place to put the x. So it says if you're plugging in an x that's greater than or equal to 3, the answer is just going to be -2 no matter what. So what do you get if you plug in 100? -2. Okay, so for these ones, the domain and the range are going to feel a little bit trickier. So we're typically going to look at the graph to find the domain and range. And the domain is all of the x values from left to right. And we're going to see if any of them are skipped. Okay, so this one has an arrow going to the left. So I know that all those negative values are going to be there. I can see that we have a value of x is -5, -4, -3, -2, -1, 0, 1, 2, and then 3 looks like it's skipped. You guys see that? But then what happens down here? I have 3. And then I've got 4 and 5 and 6 and 7 and 8, and I go right forever. So what x values do I have? All of them. So I'm going to say my domain is from -infinity to +infinity. I have all the x values. Because this one does not include 3, but this one does. And so 3 was not excluded. It keeps everything, yeah. If you didn't have 3, then you would say negative infinity to 3, 3 to infinity. And you'd put parentheses around the 3. That's how you'd show it was excluded. The range, it goes down forever. So we've got all these negative values. And then we have negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2. We like especially have negative 2. You guys see that? And then negative 1, 0, 1, 2. And then above 2, we see that there's a value there it doesn't quite get to. You guys see that? So I'm going to say my range is negative infinity up to whatever this value is. Can you guys tell what piece of the graph that is? Of the 3 pieces, what piece was that supposed to be? It's the square root piece. So we have, and we can kind of tell because this is the top piece, there's our cubic piece. This is our bottom piece, that's our horizontal line. And then this piece in the middle is the square root. You guys see that? So if I want to know what the y coordinate is for the square root graph at an x coordinate of 3, how can I find that y coordinate? Yeah, plug it in. So if I plug in 3 right there, what do I get? Square root 6. Now, am I including that point or not including that point? I am not including that point. That one gets a parenthesis. Okay? All right, any questions so far? So what method did I use to find the domain and range? How did I do it? Yeah. 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 So I look for domain, I look from left to right. And for range, I look from down to up. And I just want to see what values are there and what ones get skipped. All right, so for increasing interval, I'm going to think about putting my stick figure on the graph. And I always put my stick figure on the left side. We go from left to right because we're in America and that's what we do here. Okay, so there's my stick figure. And what is he doing first? Climbing up or down? Up. You're like, climbing, that makes sense to go up. So it's increasing, and then it levels off, but it's really still increasing, and it's increasing. And then the stick figure falls into the hole and dies. We don't know what happens to him. And then we have a new stick figure who starts right here. And he's not doing anything. This is what we call constant. He just walks straight. He's not going up. He's not going down. It's just constant. Okay. So what we need to do is we need to know the x value where he starts. So what is the x value of a left arrow? Okay, so we've got negative infinity. And then we need to know the x value right here. What's the x value? 3. And then what's the x value right here? 3 as well. And what's the x value of a right arrow? Infinity. Okay. So what should I say for the increasing interval? Negative infinity to 3. What should I say for decreasing? None. It never decreased. And then I'm actually going to add a different one in here. I'm going to say constant interval. What am I going to say for constant? 3 to infinity. Okay. So when we look for maxes and mins, they're going to look a little bit different today. Maxes and mins are just going to be a high point on the graph or a low point on the graph. And when we look at this graph, we don't have any high points or low points. And the reason I'm going to say that is because like this is a little bit smooth. It looks like it could be the top of a mountain, but then it keeps going up. So that's not a little mountaintop. That side of it looks like it could be the bottom of a valley, but then it keeps going down, so that's really not a minimum. All right, so for max and min, we're going to put none. If you look at the next picture, I know we're not on the next one yet, but you can actually see that the next one does have a max or min. Can you tell which one it has? Yeah, it's a minimum. It's right here. So anytime when we're looking for max or min, we're looking for little mountaintops or little valleys. If it doesn't have those, and these graphs often won't, then we're just going to say none. All right, what do I mean when I ask for intercepts? Yeah, where it crosses the x-axis, where it crosses the y-axis. Okay, so the x-intercept right here is what? Okay, and I'm going to say -3, 0, because it's asking for all types of intercepts, x and y. And if I just say -3, that's kind of confusing. I want to know which one that is. All right, and then the y-intercept here is going to be a little bit harder to find. How do we get a y-intercept by hand? Plug in 0 for x. So what, and we already did that, right? What did we get when we plug 0 in for x? Square root 3. So our y-intercept is actually 0 square root 3. So we have one x-intercept, we have one y-intercept. You could always use your calculator to find the intercepts, but on this particular assignment, you don't really need to use your calculator for them. Most of them are pretty visible. Is the graph continuous? So if we trace it, so start on the left side, we can trace up, it swoops, it goes up here, and then how do I get from here to the next part? I pick up my finger and I trace some more. So is this continuous? No. In fact, you might notice that most piecewise functions seem to not be continuous. You often have to pick up your finger. Okay, so next we have to do the end behavior. So we're going to say as we look to the left and as we look to the right. So what happens to the y coordinate when you look on the left side of the graph? It goes down. So I'm going to say y is going to -infinity. Y is going down. What happens to the y coordinate when you look on the right side of the graph? It doesn't stay at 0 though. What does it stay at? -2. It doesn't go up, it doesn't go down, it stays at -2. So this is the right side. So left side would be over here, the left part of the grid, the right side is the right part of the grid. So on the right, yeah. So when I say as x goes to -infinity, I really mean left side. When I say as x goes to +infinity, I really mean right side. Okay. All right. So when we look at piecewise functions, the characteristics are still there. We're still looking for them the same way, but they get a little bit more, they get a little bit less clear. Does that make sense? Because the graphs look a lot crazier. So we can still find the same things, but we're going to have to work a little bit harder to get to them. Okay, let's look at the next one. So first we're going to plug in -6. And which of the two pieces can I plug in the -6 for? The first one or the second one? The first one. So -6 is less than -3. So we've got -6 plus 4 squared. Give us 4. So that's -2 squared, which is 4. Which one can I plug in -3 exactly? Yeah, the second one. So we're going to have negative of -3 minus 3. What does that give us? 0. So minus minus makes a positive, so 3 minus 3 is 0. Which one can I plug 0 in for? The second one. We have -0 minus 3, -3. And then which one can we plug 10 into? The second one. -10 minus 3. Okay. So domain, we're going to look at the graph from left to right. So if I look from left to right, I can see I've got all these numbers on the left. I've got them all. This one skips -3 for an x coordinate, but this one right here gets the -3. And then we've got them. So what do I put for domain? -infinity to infinity. It seemed like we would maybe skip -3, but we didn't skip it. We do have a number there. All right, and then for range, we look from down to up. We got -infinity to infinity. No values are skipped there. All right, increasing and decreasing. I'll go ahead and put my little stick figure guy. What does he do first? He decreases, and then he hits this x value right here, and then what does he do for just a little bit? Increases for just a little bit. And then he falls into that hole and dies, and then we have a new stick figure. And what does the new stick figure do? Decrease. Okay. So a left arrow is what x value? Okay. And then we have the x value right here, which is what? -4. And then we have an x value right here at that hole. What's the x value there? -3. And then we have that same x value of -3. That's where the stick figure is standing. And then it goes all the way to the x value that's a right arrow, which is, what is the right arrow? Infinity. Okay. So we are going to say that for decreasing, he decreases from -infinity to, okay, so decreases from -infinity to -4. Do I use a bracket or a parenthesis? Parenthesis, always a parenthesis, no brackets on these, okay? And then his other decreasing is this straight line right here, so what should I put for that one? Okay. And anytime I have two answers at the same time, I put a U in between. It means union. I'm telling the person looking at my paper, you can't just say it's one answer or the other answer. It's both of them at the same time. You have to include both. And then I've got a little increasing interval. What are the x values for the increasing interval? -4 to -3, right next to each other. So -4 to -3, okay? We already said we had a min. Anyone remember what the min was? Yeah. Yeah, right here, -4, 0. Was there a max? Nope, none. Are there any x or y intercepts? Yes. What are the x intercepts? -4, 0, -3, 0. What about y intercepts? Zero, -3, right down there. Okay, if I trace this with my finger, is it continuous? No. And if we write the end behavior, we're going to say, as we look to the left, so as x goes to -infinity, as x goes to +infinity. All right, so what happens when we look to the left? The y value is going up, so I'm going to say y goes to +infinity. As we look to the right, the arrow's going down, so y goes to -infinity. All right. Whew. How do we feel about that? So when you're working through these, some of the answers will be really easy and obvious to find, and some of them will make your brain hurt a little bit because the pictures are not always super clear. Okay, some of the pictures are kind of hard to read for some of these. Tomorrow, your quiz is going to have stuff, I forgot to put it on the review, so I'll probably make you an extra little half-sheet review tomorrow, but the stuff with just the regular parent functions like cubic, and square root and cube root, where we needed to know how to graph those and find like their transformations and their vertices, or if they had a locator point, and then like max and min of those and increasing and decreasing of those, that stuff, that can be on the quiz. And then also the stuff that I handed you that's on the sheet. Okay, so that stuff, quiz tomorrow. First half of class we'll review, second half of class we'll quiz. Okay, make sense? All right, so the rest of the period we're working on this. Actually, I'll hand out the assignment that goes with this. If you get done with the assignment early, then you should work on your cheat sheet or the quiz review. Okay? Yes, Ms. Price? Marvelous.